Hi everyone, this is the review of Quadratics Part 1, and we are going to go through all of the things we've talked about in this unit. First off, in your package you will see Review of Quadratics Unit 1, 3.8, and this is the worksheet and the complete explanation of all the concepts that you will have on your test. Part 1. Graph the ordered pairs in each table and join the points to form a line or a curve. You'll notice that there's an equation and there are x values which you will plug in to find the y value. How do you do that? Well, we take -5 and plug it in for x for the first line. So it would be y equals bracket -5 plus 2 close bracket squared minus 5. And what you would do is type this into your calculator exactly as you see it. When you plug it in, you will find out that y will equal 4. And continue to do the same thing by plugging in the x value. That is, y equals -4 plus 2 in brackets all squared minus 5. Type it into your calculator and you will get -1. And again, you type it in, y equals bracket -3, which is what we're plugging in for x this time, -3 plus 2 all squared minus 5 equals -4. And we do it again for -2. Plug it in, y equals -2 plus 2 all squared minus 5, and you get the value of -5. Again, we plug in -1 into the equation. Y equals bracket -1 plus 2 close bracket squared minus 5 equals -4. And again, we plug in 0. Take 0, plug it in for x, and we get y equals 0 plus 2, close bracket squared, minus 5, and we get the value of -1. Again, take 1, plug it in, and we get y equals, open bracket 1, plus 2, all squared, minus 5, is equal to 4. So what do we do now? Now, folks, we're going to find the first differences. That is, how does the number change? From 4 to -1, you'll notice the numbers go. So these are all the numbers. I'm just going to re-highlight them so that you can see these are the numbers we're looking at. Not the x values, but the y values. We are comparing them. So to go from 4 to -1, we are going down 5. That's right, down 5 to get to -1. Then from -1 to -4, we are going down 3. Don't forget the sign, folks. From -4 to -5, we're going down 1. And then on the other side, from -5 to -4, we are actually going up 1. So don't forget the sign, folks. Then from -4 to -1, we are going up 3. And again, the last one, from -1 to 4, we are going up 5. So this is my first differences. You'll notice that these are not the same. If they were the same, it would be linear. But because they're not the same, we continue the pattern at the next level. That is, how are these numbers changing? From -5 to -3, it's going up 2. From -3 to -1, it's going up 2. From -1 to 1, we're going up 2. From 1 to 3, we're going up 2. And again, from 3 to 5, we're going up 2. And what you see is these values are the same. So what does that mean? That means we're dealing with a quadratic. How do you know that? Well, 2 reasons. The second differences are the same. And if you look at the equation, there's a square, folks. And remember we said if the highest power is a 2, then it is a quadratic. So there are 2 ways to tell here. The next way we're going to show is by graphing this. We are graphing these coordinates. -5 to -5, +4 is located here. -4, -1 is located here. So -4, -1. -3, -4, my next point is going to be located here. And then we go -2, -5 is located right here. And then we have -1, -4, so now we're hitting those mirror image points. Okay, the next point is going to be at 0, -1. And then the next point is going to be at 1, 4. 1, 4, folks, right there. And notice there's our mirror image points. Now when we draw the parabola, we must draw a smooth, rounded curve. So it can't be pointy here. It's got to be rounded. And make sure you put the arrows. The arrows are just as important as the rounded curve, folks. And make sure your curve is going through the points. This here is the parabola that represents this equation from this table, showing that the second differences is 2. Okay, so now we have to answer some questions that are underneath. For example, it asks us here, the parabola opens which way? Hopefully you can see that these arrows are pointing upwards. That's right, so the parabola opens up. It has a vertex of, where's my vertex? Let's see. If we look on this graph, you should be thinking, okay, there's the vertex. It's the vertex because it doesn't have a mirror image. It is the lowest point in this parabola. Okay, so my vertex is going to be -2. So looking here, the coordinates of this is -2, -5. That is those are the coordinates for my vertex. Now this parabola has a jump. How much is it jumping by? Well, if we look over from the vertex, it jumped 1 over 1 up 1, over 1 up 3, over 1 up 5. So it has jumps of 1, 3, and 5. That's right. 1, 3, and 5. And we can also see that from the A value, the number that's after the equal sign. That number after the equal sign before the bracket represents the first number in our jumps. All right, let's go to the next part. The next part talks about part 2, graphing complete the following table and graph each parabola. So you have the ability now to be able to graph a parabola by just knowing how it opens, the vertex, and the jumps. How do we do this? Let's start with how it opens. if we need to identify the a value, the a value here is equal to 1. The a value is equal to 1. That would be right here is where the a value is found. Since the a value is positive, we can say the graph opens up. That only happens when the a value is positive. It opens up. And now let's do the next one. The a value for part B. A value is equal to 2. Positive 2 a value. So this one also opens up. This one, we're looking at the a value. The a value is after the equal sign, before the x. And we have, or before the x squared, we have a is equal to -1. Because it's negative, the graph opens down. Now let's identify the vertex. Remember that for all equations, we have the general equation for the vertex form is y equals a bracket x minus h all squared plus k. My vertex is hk. That is the opposite of what's inside the brackets. And then k is the number after the square. So in here, we're looking at opposite the inside of that bracket. That is, opposite of +3 is -3. -3 is my h, and my k is the number that's after the square. That is +1. So -3, 1 is my vertex. Let's do the same for the next question. Opposite of -1 is +1, comma 6. 1, 6 is my vertex for this equation. Let's go again to the last one. This one has no brackets. So when it has no brackets, we automatically write 0 for our h. 0. 0 what? Well, it'll be 0, 5. That is our vertex for the parabola in this question. Jumps. How does our parabola jump? Well, it has to do with the a value. The first number is always a, 1 times a, so 1 times a. Our second number is always 3 times a, and our third number is 5 times a. 1a, 3a, 5a. So my jumps in the first one would be 1 times 1. 1a is 1. 3 times 1 is 3. 5 times 1 is 5. So my jumps for the parabola are 1, 3, 5. The next one, my jumps will start at 2. That's 1 times 2 is 2. Remember 1a, 3a, 5a. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. All right, moving on to the next one. A is -1. So it's 1 times -1, which is -1. 3 times -1 is -3. And 5 times -1 is -5. And that's how our parabola is jumping for the third one. Next thing we have to do is graph our parabolas. If you remember how we started graphing in this unit, we used our vertex to start it off, and then we used the jumps. So starting with the vertex, so we're going to graph part A here. So we start with the vertex, finding the vertex, which is -3, +1. We are going to plot our vertex right here. Next, we're going to use our jumps. Our jumps are saying we move over 1, up 1. And then that has a matching point on the other side. Oops, that's way too much. Let's go back a little bit. and move a little forwards here. So we're sorry, folks. We'll get there in a second. And what we're doing here is recapping everything we have here with respect to our jumps and how to draw this. So slowly we find our vertex. We jump over 1, up 1, then over 1, up 3, then over 1, up 5. And we end up here. So over 1, up 1, over 1, up 3, over 1, up 5. And all of these points will have a mirror image on the other side of the parabola. So over 1, up 1, over 1, up 3, over 1, up 5. And there they are. And what you'll do now is graph the parabola. Remember, a smooth rounded curve with arrows pointing in the direction of opening. And that's all, folks. That's how you graph it. Why don't you try the next one? Pause the video and try the next one before you play the video again and see if it'll match my answer. Go ahead and pause now. Okay, we're back. And hopefully you graphed the next one. The next one are going to do, first we graph the vertex 1, 6, and we're going to graph as much as we can. Remember, it doesn't always fit on the graph, but I promise you that on the test, just like it was on the quiz, that you'll have a chance to graph it. At least, we want to have at least 5 points. In this case, we're only going to be able to fit 3. It's okay, folks. It's because of where the vertex is located and how it opens that we ran out of space. So we graph it, smooth rounded curve, and put the arrows at the end. All right, there is our second graph. Now our third graph, a little bit trickier because of the fact that it opens down. But that's okay, folks. We can do this. First off, graph the 0, 5, which turns out to be our y-intercept, which is also our vertex. Not always the case, but this case it is. And we're going to graph over 1, down 1. That's right, because it's -1. Over 1, down 1, and match the point. Over 1, down 3, and match the point. Over 1, down 5, and match the point. How did I get that? Remember, this is our jumps. Down 1, down 3, down 5, and you're just moving over 1 each time. Graph the parabola like such, and don't forget that it's a smooth, rounded curve with arrows pointing in the direction of opening. All right, so that is question number 2. Moving on. Looking at this, you're going to have to be able to identify different parts of the parabola. Looking at the equations, we want to know, how does the graph open? Well, the graph has to deal with first understanding the vertex form of a parabola. There's the vertex form up there. We saw it earlier. Y equals a, x minus h squared plus k. So our opening is our a value. Our vertex is our hk value. Don't forget the brackets around it because that is a set of coordinates, x, y, hk. Our jumps are always 1a, 3a, 5a. We just did an example of that just a moment ago. Now, something new that's added is axis of symmetry. That's not new. We have done them, but I just want you to be aware. The axis of symmetry. The axis of symmetry is x equals h. That's right. The x value of the vertex, also known as h. X equals h is our axis of symmetry. It's an equation. And then the optimal value, you will always tell me whether it's a max or a min. Max if it opens down, a minimum if it opens up, and the value. The value is k, folks. That's right. The k value of the vertex represents your optimal value. So let's look at this first one to be able to answer the questions. This graph opens down. Why? Because the a value is negative. Now, the coordinates of the vertex, opposite of what you see here, so it's -7. And the k value is the number after the square, which is 0. Our jumps are always 1 times a, 3 times a, 5 times a. My a value is -2, so it's going to be -2, -6, and -10. Now, the axis of symmetry is x equals h. Here is the h right here. So in this case, it's over here. X equals h means x equals -7. That's basically the x value of the vertex. Optimal value, because this graph opens down, we look at this down. That means it's a maximum. It's a maximum of how much? Well, we look at the k value. That is the k value of the vertex, which is also the y value of the vertex, which is 0. So this graph has a maximum value at 0. Next, we go to the next problem and do the exact same thing. So I'm going to ask you to pause the video and try this one by yourself, the next two by yourself. I'd like you to try these two by yourself as kind of a test to yourself to see, do you understand quadratics? So pause the video now. Okay, welcome back. Y equals 3x squared means that my graph opens up. A value is 3, it opens up. My HK is going to be 0, 0. 0 because there's no brackets, and 0 because there's nothing after the square, so 0, 0. My jumps will be 3, 9, 15. That's right, 3, 9, 15. You're multiplying each of 1, 3, 5 by the a value. The a value is 3. Axis of symmetry is x equals 0. My optimal value, well, this graph opens up. Up means it's a minimum. So it's a minimum of 0. All right, let's try the next one. Looking at this, what you're going to do is follow this same thing that we said. Okay, as we did earlier, you're going to follow the same thing. Hopefully, you've done that. Down, because the a value is negative. My coordinates of my vertex are -4, -8. Don't forget the brackets. My a value is -1. And 3 times -1 is -3. And 5 times -1 is -5. My axis of symmetry is x equals -4. That is, we get that from x equals h. That's this value here. And finally, my optimal value, because this graph opens down, it has to be a maximum of how much? Well, that depends on the y value. So in this case, it's a maximum of -8. Hopefully, you are starting to understand how to identify different parts of a parabola. Next up is section 5. Find the equation in vertex form of the following parabolas. Provide a complete algebraic solution. So you can't just guess and check. You can't just graph. You need to show me that you have an understanding algebraically. Algebraically means that we're going to do some work. That's right, some mathematical work. What we have to do is substitute for h and k. That is, we're taking the vertex and plugging it in for h and k. We have a random point. So we're going to sub that random point for x and y. Where are we subbing it in? Well, we're subbing it into the vertex form of a parabola. That is y equals a times x minus h squared plus k. We're plugging in the different parts. So 2 will go for h, 2 will go for h, 8 will go for k, -1 will go for x, and -19 will go for y. So when I plug it in, my y is -19 equals a, which is what we don't know. Remember, we don't know what a is. X is -1 minus h. My h is 2, close bracket squared, plus k. My k is 8. Okay, so just a reminder how I did this. 2 is for h, 8 is for k, -1 is for x, -19 is for y. And I just plugged in all the pieces. What am I missing? The a value. We need to find that a value. How are we going to do that? Well, we need to do this in parts. So -1 minus 2 all squared is the part that I need to find out first. -1 minus 2 is -3. All squared is 9. So a, -3 all squared, plus 8. -19 is equal to 9a plus 8. This is -3 squared is -3 times -3. That's 9 times a plus 8. Move the plus 8 to the other side. We leave the 9a where it is. We move the plus 8 to the other side. And it becomes -19 minus 8, which is -27. Once you do that, you divide both sides by the number next to a. So we're dividing both sides by 9. We divide both sides by 9. We get a equals -3. So we found our a value. So our equation is going to be y equals, so a equals -3, h equals 2, k is equal to 8. So my equation is -3 x minus 2 all squared plus 8. What we need is the values for a, h, and k. We leave the x and the y the way they are. So this is our equation that we found using algebra. All right, next piece. Axis of symmetry, x equals -5. Optimal point is 9, and our y-intercept is 19. What information are you given here? Well, folks, this number right here, the x equals -5, represents h. The optimal point represents our k value. That's our optimal value. Y-intercept represents 0, 19, which is a point on the graph. So we do the same thing that we did before. You're going to sub -5, 9 for h and k. We are going to sub 0, 19 for x and y. And where are we going to do that? Well, we're going to do that in y equals a, x minus h all squared, plus k. That is 19 equals a bracket 0 plus 5. So we're plugging in the numbers. So x minus h, x is 0, minus h. So minus 5 turns into plus 5, all squared, plus k. K is 9. All right? And we get 19 is equal to a times 5, all squared, plus 9. 19 equals 25a plus 9. We move the plus 9 to the other side. We get 19 minus 9 equals 25a. That is 10 is equal to 25a. And we divide both sides by 25. And we get a is equal to 10 over 25. That means a is equal to, when we reduce it, to 2 over 5, or 0.4. I would have to accept both options. So our equation will be a equals 2 over 5, or 0.4, h equals negative 5, and k equals 9 into the equation. So we have y equals a, which is 2 over 5, times x minus negative 5, which is x plus 5, because that's our h, and then plus 9. Or if you had decimals, if you decide to use the decimal, you would have y equals 0.4 bracket x plus 5 all squared plus 9. I would have to accept both answers, folks. The fraction, though, I will tell you, always plays a special important role in my heart, meaning that it's always exact. A decimal sometimes has some issues, but thankfully in this case it doesn't. Okay, moving on to the next question. So you're asked to complete the chart. So what we also talked about in this unit is not just vertex form, but also factored form. So how do it tells us the roots of the actual graph. That means our x-intercepts are zeros. So we need to be able to identify what parts we know about the graph when it's in factored form. What does that mean? Well, in this case, we look at the brackets and we find out what number will make this 0. Now, some of you are like, what? What does that mean? Well, we taught you a little trick. The trick was to look at -3 and think the opposite because it's in brackets. Remember, we did that with h. So, opposite of -3 is +3. So, x equals +3 as one of my roots. Our x-intercepts are zeros. So remember, x-intercepts, roots, and zeros mean the exact same thing. So x equals 3 is one of our roots. X equals -7 is one of the other roots. So opposite of what you see in here, +7, it'll be -7 when you pull it out. Now, next, we need to find the axis of symmetry. Now, the axis of symmetry is exactly halfway between the zeros, halfway between all points but the vertex. So halfway between their matching points. How do you do that? Well, we taught you a formula. That formula was x equals p plus q divided by 2. That is my roots, p plus q divided by 2. So it'd be 3 plus -7. Press equals in the calculator, then you divide by 2. So 3 plus -7, then divide by 2. So you have to do the top first before you divide by 2. So you should have gotten, if you did that in your calculator, 3 plus -7, press the equal sign, then divide by 2. The answer here will be -2. Next, we need to do is find the vertex. How do we find the vertex? Well, folks, we need to sub. What do we sub? We sub our axis of symmetry, because remember that's our h value, into the equation y equals 2, bracket x minus 3, bracket x plus 7. We already have the equation. We just need to find the k value. This is my h. Okay? And now we need to find the k. So to find the k, we take y equals 2 bracket x, which is negative 2, minus 3, times x, which is negative 2, plus 7. We plug that into our calculator and you will get y equals, okay, so we need to do, I'm just showing a little bit of math. It's okay to show a little bit of math. Just in case you make a mistake, I can see what you're doing in the work. And you will find out that the answer is negative 50. So my vertex is going to be h, which is negative 2, comma, negative 50. Oops, that's a lot of work there. Let's erase that. And note here, vertex is negative 2, negative 50. Okay? So that's how we do that one. Let's move on to the next part. And we try this again with this question. So again, y equals negative 3, bracket, x plus 2, close bracket, x plus 14. We need to know the roots first, the x-intercepts, the zeros. That is x equals negative 2. That is the opposite of what we see in here. And x equals negative 14, which is the opposite of what we see here. So those are my roots. Next step, we have to add these up and divide by 2. What will that give us? That will give us our axis of symmetry. So x equals negative 2 plus negative 14, all divided by 2. So we need to first add these up together first, press equals before we divide by 2. When you do that, you will get negative 16 divided by 2, which is negative 8. Negative 8. X equals negative 8 is our axis of symmetry. Next, we need to find the vertex. We have our h value, we need our k. So we sub x equals negative 8 into the equation y equals negative 3, bracket x plus 2, close bracket, bracket x plus 14. We plug it in and we get y equals negative 3, bracket, negative 8 plus 2, close bracket, negative 8 plus 14, close bracket. Type this into your calculator. If you need to show me a little bit of work, that is always good. A little bit of work doesn't hurt. You will get the answer of 108, positive 108. So my vertex will be negative 8, 108. All right, so moving on to the next part. Determine the equation in factored form of the following parabola. Remember that factored form in your notes. You will notice that it is y equals a x minus p, x minus q. P and q are our roots. So one of these is p and one of these is q. One more time again, y equals a x minus p, x minus q. So x minus p, times x minus q represents our parabola in factored form. So we need to find our values. So what are we going to do? We are going to identify the different parts. This is P. This is Q. This is my vertex. Okay? So we're going to sub our vertex this time for x and y. It's a random point, folks. So we're going to sub it in for x and y. Remember, we don't have h and k in this equation. We have p and q. P and q represents the zeros. So we sub -1, 3 for x and y. P equals -4 and q equals 2. In the equation, y equals a x minus p times x minus q. So we are plugging the information in. When we plug in the information in, we're going to replace y with 3. So 3 equals a bracket x will be -1, -1 minus -4, close the bracket, times open bracket, x, which is -1, minus q, which is 2, and close the bracket again. So we're putting in the information into this formula to look for a again. 3 is equal to a times -1 minus -4. You would get 3. And -1 minus 2 is -3. 3 is equal to 9a. That means my a is equal to 3/9. When we reduce that, we get a is equal to 1/3. So our equation is going to be, will be the following. We're going to use a equals 1/3. We're going to use p equals -4. And we're going to use q equals +2. And the equation will be y equals 1/3 bracket x minus p. So -4 becomes x plus 4. And then the other bracket will be x minus q, which is 2x minus 2. All right, we have y equals 1/3 x plus 4 times x minus 2. That represents the equation with this type of parabola. Okay, moving on. We have a bunch of expand and simplify. So that was all that rainbow stuff that we did a little while back. If you remember, what we did is we multiplied x times x to give us x squared. So we're going to multiply these. First, I'll show the rainbow, and then we'll get started into trying to do this by yourself. So, first off, let's expand and simplify part A. That is, x times x gives us x squared. And I'm going to do it in colors so that you can see what I'm multiplying. X times -9 gives us minus 9x. And then we go underneath and multiply -3 times the x, which gives us minus 3x. And then again, the -3 times the -9, just like this, -3 times the -9, gives us plus 27. So when I get the full answer, my answer will be x squared minus 12x plus 27. And that, folks, is this expanded and simplified. We're always going to simplify these two pieces in the middle, and we will always start off with, if we have 2 pieces times 2 pieces, we should have 4 pieces that we multiplied. And then what we would do is simplify the middle piece. So let's try that again, using the colors one more time. 3x times 7x will give us 21x squared. 3x times plus 4 gives us plus 12x. Minus 2 times 7x is going to be minus 14x. And then finally, minus 2 times plus 4 gives us minus 8. What do we have here? What you will have here is now the simplified form, which will be 21x squared minus 2x, because we're collecting the like terms here, 12x minus 14x, and then minus 8. If you have any questions about any of these, please come and see myself or any math teacher to help you understand how to do these questions. Moving on to the next one. We talked about how to deal with squares. And if you remember, what I did was I told you, take the square away and put a bracket. What are we bracketing? The 2x minus 3. So we double the 2x minus 3 because there was a square. Now what do? We do the exact same thing we did for A and B. We do it for C. That is 2x times 2x, which is 4x squared. 2x times minus 3, which is minus 6x. Minus 3 times 2x is going to be minus 6x, and minus 3. Let me just change the color up, folks. Sorry. Minus 3 times minus 3 is going to be plus 9. So my final statement will be 4x squared minus 12x plus 9. All right, part D. Let's move on to part D. Part D is a little tricky. The tricky part is remembering what to do. That is, work with the double set of brackets first, leaving the minus 2 outside. So, what are we doing? We're multiplying out across. 4x times 3x, which is 12x squared. 4x times minus 5 is minus 20x. Plus 1 times 3x is plus 3x. And plus 1 times negative 5 is minus 5. And what do we do now? We collect the like terms inside those brackets just to make it a little bit easier to work with. That is, we will have 12x squared minus 17x minus 5. Where did I get the minus 17? Well, that's 20x plus 3x, negative 20x plus 3x, which will give negative 17x. Now what do? We now can take that negative 2 that's been patiently waiting outside and multiply to each piece on the inside. That's right. Negative 2 times the 12, negative 2 times the negative 17, and negative 2 times the negative 5. You will get negative 24x squared plus 34x plus 10. Okay, a little bit of algebra, folks. And do the same for part E. I'd like you to pause the video and try part E. Welcome back. All right, let's see if you got the same answer that I'm going to get. 7 bracket 3x squared plus 6x plus x plus 2. The next line you should have gotten was 7 on the outside, 3x squared plus 7x plus 2. And then my final answer is when you expand out that 7 and multiply it to each piece, and you get 21x squared plus 49x plus 14. Hopefully you got that. All right, last but not least, this one. Be careful with this one, folks. You probably should rewrite it so that you have all the pieces done properly. That is, x plus 4 all squared is x plus 4 times x plus 4. So 2 on the outside, x plus 4 times x plus 4, minus 17. So, step by step, leave the 2 on the outside and expand the double set of brackets. Leave the minus 17 on the outside. Expanding the double set of brackets, that's these two brackets, we're going to expand it, go x squared plus 4x plus 4x plus 16. So my next line will be 2 bracket x squared plus 8x plus 16, and then minus 17 on the outside. As a result, my answer will be 2x squared plus 16x plus 32. So that means I give the 2 to each piece. I don't give it to the minus 17 because it is not inside the bracket. And my final answer will be 2x squared plus 16x plus 15. That's right, 2x squared plus 16x plus 15 is my final answer. Okay, and I'm going to just move that up a little bit so you can see it. There we go. That is my final answer. All right, folks, that's the end of the review. Hopefully this helps you. You can watch this video over and over just to make sure you understand what is needed to be able to pass this next unit test. Have a numerical day, folks. Take care. Bye.